Hi, Precalculus students. So here is your homework notes. This is the front page of our flipbook that we've already done. We're going to take our notes on the second page, and it's going to be labeled logs as inverses and graphing logs. Okay. So at the very top of the page, actually just so you have a general idea, we're going to divide this about in half. And then down here, we're going to divide it. The top will be a little bit bigger, so you get an idea. Up here, I'm going to write logs and exponentials are inverses. We should all know this. Logs and exponentials are inverses. And I'm going to graph these to kind of show that in a picture. So my x-axis, or my y-axis, my x-axis. I'm going to go up to 8 on each of these. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oops, no, whatever. Okay. So I'm going to graph my exponential graph in blue. And I know that my exponential is going to be the equation y equals 2 raised to the x. And in order to get an accurate graph, we could make a little xy chart. I'll plot the points 0, 1, 2, 3. So 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, and then 2 to the third power is 8. So I'll plot my points. 1, 1, 2, 2, 4, and 3, 8. So my exponential graph is going to go up from here. And then I know that exponentials never go below 0, so it'll just follow this asymptote there. So in blue, I have my exponentials. Now, I can also graph in orange my log. So y equals log. My base is still going to be 2 to the x. And to graph a log, it's the inverse of an exponential. So I know to get the chart of an inverse quickly, I can just switch these x and y values. So inverses, remember, you can just switch x and y. So instead of 0, 1, I have 1, 0. Then I have 2, 1, 4, 2, and 8, 3. So from the blue to the orange, I just switched my x and y. So 1, 0, 2, 1, 4, 2, and 8, 3 is here. This one never crosses your y-axis, so it goes up like this, like that. Looking at these two graphs, it's easy to see that they're inverses, because they're a reflection of each other over this line that's y equals x. The line of symmetry. So there's graphing a log. This is what the log looks like graphed. The inverse of an exponential. Okay. And then down here, I'm going to write the definition. And we all know this. The definition is y equals log of b of x. We know this because we know that the exponential is this. So if we look here basically our y in the log becomes the exponent in an exponential. We know that the base of the log is the same as the base of the exponential. And then the argument of your log becomes the answer in the exponential. And some common logs that you're going to see are, we have log of x. We know that if there's no base explicitly written, then it's log base 10 of x. So this is base 10. And we have what's called the natural log. When it's like that. The natural log means that we have a log with base e. This is called the natural log. And e is just a number similar to pi. It's just kind of a number that goes on and on and on. So we just call it e. It's similar to pi. Cool. So over here, I just want to give some quick examples. This is stuff that you've done before. First we can rewrite in log form. So if I had 1 over 12 squared equals 1 over 144, like that. Using this definition, I can rewrite it. So right now it's an exponential. I can rewrite it as a log. This would be log. The base is going to stay the same, so 1 over 12. The answer becomes the new argument, so 144 equals 2. I'll write another one. This one's 9 of y equals x. And this can be rewritten in log form. The base stays the same, so log of base 9 of x equals y. Yay! And then we can do examples of rewriting in exponential form. So rewrite in exponent form. If I had log of base 14 of 1 over 196, this equals negative 2. And I can rewrite that. The lights just turned on. I can rewrite that. The base stays the same. So 14 of negative 2 equals 1 over 196. Then B, I could write log of 169, 13 equals 1/2. And using the definition, I could rewrite this as an exponent. Using the base raised to the answer equals what's in the argument. So this is just rewriting what you did last week. And then some examples of this, you could say evaluate. Let's see. A, B, C, and D. Log base 5 of 25 equals, well, I have to think about what would the exponent be here. What exponent would I put in here to equal 25? That would be 2. Or here, if I have log base 6 of 1 over 36, you have to think, what's the exponent that I would put on the 6 to equal 1 over 36? And that's negative 2. One that you may have to think about, what exponent would I put on this 8 to equal 1? This one's a little tricky. The exponent would be 0, because anything raised to the 0 power is equal to 1. And then one with e, if I have log base e, and the argument is e squared, what exponent would I put on the e to equal e squared? You'd put 2. Okay, so evaluating logs, remember to use the definition and think about, relate it back to exponents. Okay, so here are your beautiful notes on logs as inverses and graphing logs. Bye.